Hello guys, today I have a challenge, and the challenge will be to create a rocket engine like LEAP71 is doing with their PicoGK in as short time as possible. Quick note is that I didn't do any stuff in PicoGK from the last video. This should be fun challenge. So actually AI is gonna build our engine. So first of all, we will install Codex. You click on download and view it in store and download it in. You will get icon like this. You just click this icon and it will open Microsoft Store and it will install Codex. Second thing is that you need to have ChatGPT Plus in order to use Codex. Don't go away yet because you know that ChatGPT Plus costs like 20 euros, but on this site you can get it for around $3 to $5 per month. So yeah, it's like 10x cheaper than regular subscription, but it is so powerful, guys. It is so worth it. I've built so many things with it. It's like two of you working on the same project, literally. I mean, it's not perfect. The code you write, there is like millions and millions line of code that should be reviewed. But yeah, you're doing just review part of the code. Even if you don't like reviewing your code, you can write to Codex to make your code cleaner and better. So yeah, sign it in the Codex and we will create a new project, Rocket Engine, and we will add this path, test and Rocket Engine, select folder, and every code that he writes, he will write inside this folder. Second thing we need to set up is, before we start this challenge, I want you to keep in mind that prompting is not just, you cannot just write him up like you want a rocket engine. This won't work because it's too general. I mean, if someone is standing in front of you that knows how to build a rocket engine, you cannot tell him this because there is a lot of unknowns you need to give him. Like if you're going to buy a car in the shop, you need to tell that person what kind of car, what color of the car you want, what horsepower you want, what design of a steering wheel you want. Do you want a sport line of a car or you want like cruise? Everything can be as complex as that. So actually we'll do something, we'll be more lazy than this. So we'll go into ChatGPT and we'll say standard thingy because we don't need him to think so much. So here I asked ChatGPT to give me a prompt, which will actually be some kind of master prompt that will be used for future handling of the conversation and app development. So I think of this prompt, this first prompt is the most important prompt. It's like the main.py. So if you don't include some library that you build in this main.py, it won't work. Yes, you can do patches and stuff like that, you can include it later, but from the first try it won't work. So actually I think he overdone it. Okay, I want this shorter version. Okay, so basically he gave me bullshit answer because I was not very direct what I want. Actually, we'll write something different here. This part is okay, but we don't need safe and legal and non-operated educational research use. I mean, we need research use, yeah, educational, but we don't need this part. But okay, we will be lazy and we'll just give it, we'll put reasoning to high because high is thinking a little bit more than medium, but medium is thinking too short, you know. And high is giving better answers than medium, so yeah. So we as engineers always need to go to the documentation when we want to write something. So that's what I told him. My idea is to create rocket engine using PicoGK. I want you to scan and go through all the documentation they have on the website and GitHub. So yeah, this will narrow down his vision of what we want to create. So now I ask him to give me actually all the things that he needs in order to create this nozzle. But yeah, this is what you get if you write wrongly your master prompt. Okay, so he asked me about this. I mean, this is wrong. This is what I don't want. There are still a lot of unknowns here, like chamber pressure, what kind of mixture we want in our rocket. Is it gonna be what kind of temperature in the chamber will be? What programming language? Okay, so right now we are inside VS Code. This is my old setup, so I don't know if it's actually working. So we'll see now. .NET.run. Something is... Oh, did something. I don't see him nowhere using actually equations. Okay, so as in the past I have designed rocket engines, so I knew that I didn't use thermodynamic equations for nozzle geometry, so I actually told him to do it. This is why he don't want to give me. So yeah, I will try to give him the lie that I am PhD student doing research. Stupid AI, stupid me, because I listen this AI. I am. Now I'll tell him to be more scientific. So we'll see now. Prompt I will create new. See what goes now. Active senior version. Okay, this is also a little bit not how I exactly wanted it to be, but okay. We'll test this one more time. We'll delete this because we don't need this. And now we will give him this same prompt that he needs to research about PicoGK, and we will also tell him this thing, and we will also expand that prompt with this. Okay, so I told this ChatGPT to give me the prompt how it look like, because everything is in writing good prompt, guys. Okay, so he gave me this prompt, but I will delete something from this prompt. Defined calculation workflow. Okay. We want this, so we need to remove this from me. Yes, this is what we need. Good. I think this is like 8 out of 10 prompt. It could be shorter. So what I like to do is dividing this big prompt in a lot of smaller prompts, because as engineers we already know what we need to do. So AI will be more precise if you give him a lot smaller prompts than this one big prompt. I mean, this is not the problem with newer models of ChatGPT. With older ones was big problem. Just keep that in mind. Actually, he gave me here all of equations that actually look like rocket equations. So we need to give him P0, which is pressure inside combustion chamber. Also temperature inside combustion chamber, gamma, which is specified by burned mixture, also R, and molecular mass, I guess, atmospheric pressure, and he needs either force, a force so that will this engine give us, mass flow rate, or throat area. I won't give him this, so I told him here that I'll use stoichiometric mixture of methane and oxygen. So I already knew that Cantera and NASA CA. Cantera is Python module and NASA CA is calculator from NASA. So yeah, I'll just tell him that he uses the same logic for calculating this stuff. I'll tell him that he should ask me if I didn't explain something very well. Okay, so it gave me some kind of formulas that are relevant. Yeah, he didn't write any code, so So I'll now tell him to give me a code that will just calculate just it. Okay, so it's generating something. So it wants me to say yes, and yeah, I will click on this. So I want, if he wants to check it, I want. Okay, so he gave from my initial prompt, he gave me throat diameter of 54 millimeters, which is relatively good because I designed similar engine and it was around 50 to 60 millimeters, so I would say this is good. Okay, so I now told him to give me inlet and outlet diameter, because you know, if you Google this you will get this. So you need this smallest throat diameter, exhaust diameter and inlet diameter in order to create this contour. So I just told him to give me these 3 points, and from these 3 points he'll actually make this bell nozzle. So maybe if you are confused of what we are doing right now, so basically how engineer designs something. So he uses equations, involves math and physics. He uses these equations to get some dimensions. These dimensions are required dimensions for this design. After he gets these dimensions, he goes into the modeling program and he designs something inside this 3D modeling program, but these are constraints. He needs to respect these dimensions because these dimensions hold physics and mathematics together. So if he doesn't respect these dimensions, his design will collapse. He will, maybe rocket will explode or it will crack somewhere, it will leak. Right here he did something. He didn't give me any output. So right here he made this like entry point. This is a lot of code that I'm not gonna read, but we'll just type .NET run to run this code and let's see the output. Wow, there is a lot of output. So yeah, inputs, this is what we told him. We want 10 bar. Chamber temperature is 3000 Kelvin, which is, I guess, I don't know how he got there. So he gave me pressure that it is dropping. Temperature is also dropping. There is, at the exit there is Mach 2. Pressure is 1 bar. Temperature is dropping like crazy. Yeah, the diameter is 82 millimeters. And this is bigger than this because there is a pressure of 1 bar. If it was like lower, it would be bigger than this. So yeah. So yeah, he gave me note that this is frozen gas. This is not full equilibrium CEA solution. Sign inputs. These are inputs. Let's see what did he do in input. He defined chamber pressure, okay. Ambient pressure, exit pressure, which these are basically the same in this as in this design, but exit pressure is fluid pressure of the nozzle, and this is ambient pressure. So this will, all as the rocket goes up, this will always be fixed, but this is changing because exit pressure of fluid inside the nozzle will always be fixed. If it's a bell nozzle, if it's aerospike, then this is changing as this is changing. Okay, so he didn't do CA calculation inside here. I think we could test the design in here. Type 10 bars. Fuel is H4 gas. Oxidizer is O2 gas. This is, I think, 4 for stoichiometry. And this is 10. Okay, this is chamber, throat, and exit. So for Mach number, we get, let's exit Mach number 0.16. We got it right. But if you didn't got this right, maybe you should check these things, these factors. Because if these factors are wrong, obviously Mach number cannot be right, because these are used in the calculations. So you can also check it here. So inside the chamber, this should be the number, and you see it is not quite right, but it is very close to it. So now that we have this thing, we'll tell him that we need a bell-shaped nozzle inside PicoGK. Okay, so it did write something up, so we'll see. We'll go check it up. Okay, it gave me something. So I gave him prompt that I want to visualize this into PicoGK, but we can also visualize this STL inside, and there is our bell nozzle STL, and this is what we have got. And it gave us some curve here. Nice, pretty good. But it's not hollow. So we will tell Codex that we want this hollow geometry of rocket engine. So that's just what I wrote to him, that I want the walls to be 10 millimeters thick and the voxel size are more denser, so we have more details in our geometry. But in the meantime, we'll check what did he do. Do we get UI? I don't told him that it program is stuck. What I think that is happening is he's trying to calculate every single point cloud, I mean voxel, inside the PicoGK, and since it gave him a lot of voxels, he needs to calculate a lot of voxels. So yeah, that's a lot of time to process this. Okay, so he gave me voxel size millimeter in 0.75. That is very, very dense. Let's see, start at something. Oh, okay. You see there is something inside this geometry and it is not right. From my basic research of PicoGK, I know that how PicoGK works. So you need to create initial geometry, and from this initial geometry you need to create basically copy of this initial geometry, but a little bit bigger. And this initial geometry needs only to be scaled by one direction, not from all directions. If it's scaled in all directions, this is what will become. So what I think what happened here is that he this is initial geometry here, and he scaled it. So this is our scaled geometry, and he made a Boolean difference. And this inside is actually a hole, but it also have this cap on top and the bottom, which we don't need to. So I told him to scale it only by with this epsilon axis, or I told him just to cut this inlet and outlet somehow. So this is actually how mechanical engineers are gonna design things in future. I mean, not all of them, but if you want to do parametric design, that's design where you only do one design, but you can change initial conditions, so you get multiple designs for multiple initial conditions. That's the thing. And if you want like additional stuff on this basic geometry, then you can add later in the process. For every change in initial conditions, you don't need to do geometry manually. That's the point. So this recording took me like 1.5 hours already, and we are basically done. If we go like 10 years before 2026, this were gonna take someone like maybe 1 month of work, because he needs to understand how PicoGK works and he needs to understand logic of it, and obviously he needs also to build this program. And this is not hard, guys. Some experienced people maybe could do it in a shorter time. But yeah, so as you can see, we actually designed rocket engine with AI, guys. Our nozzle exit just got bigger because we changed the design, our initial design. Let's change it a little bit more. So as you put these numbers lower and lower, our nozzle exit should be bigger and bigger. You know how in the space they have very big nozzles? That's why. So as you can see, this is some kind of satellite maneuvering engine. So this is how they look. They have very big extensions over here. I mean, nozzle is up to here because up to here there is regenerative cooling, and from this part of the nozzle and to this part, this is all radiative cooling in the satellite propulsion systems. So yeah, you also can do a lot of more stuff with this. This is only what 1 hour can get us with €3, guys. Imagine using this 8 hours for only 1 day. You can do a lot of stuff. Engineers with this power can do a lot of stuff. Even people that didn't go to university and know how to use this will be very powerful. On top of this, tell ChatGPT that he uses dynamic thickness of the walls, so at the ends you will have very thin walls because pressure difference here is very tiny compared to inlet. Inlet has the biggest pressure difference. You can also do regenerative cooling here, and just sky is the limit, guys. Yeah, you just need to type now to be an engineer. You don't have to do anything. So actually, whoever on LinkedIn says that they're not doing AI is not doing rocket engines in LEAP71, they are false. AI can do, but background is all just mathematics that also a human can do. So yeah, that's all from me, guys, today. I taught you basics around how to design this stuff. You can create this in any other CAD program. You can also create this in Rhinoceros, in FreeCAD, any other program that has API to create 3D models. Also, you can do this in Inventor, but in Inventor it will be a lot harder to create because Inventor is a lot of closed source and not a lot of people using it. PicoGK has very good documentations on this on their website, so AI can easily scan its documentation and create code with it, you know. So you just have to be wise and thoughtful of what you choose for your technology and how to build. You need to know also the constraints because PicoGK, it's very hard to do like assembly design in PicoGK, you know. I don't know if PicoGK can do motion dynamics, but I know it has some animations inside it, so maybe that's the application for it. But I think it would be a lot harder to do it that way than doing assembly inside SolidWorks and just test dynamics inside SolidWorks, you know. So that's all from me, and I guess see you in another video. Bye, guys.